All right, we're back for part two. So let's keep going with our notes. Next question says identify the like term. So remember, anything that's a like term has to contain the same variable, and that variable has to be raised to the same exponent. So it looks like 6xy is my only term that has both an x and a y. If I look at the x's, all the terms that contain x's, it looks like there's three of them. So 2x contains a 3, 5x contains a 3, and 6x. Whoa, I think I've been saying 3. I meant to say x. So 2x contains an x, 5x contains an x, and 6x also contains an x. Next, I can look at my numbers. So 2 and 4 are constants. Remember, a constant is anything that just doesn't have a variable. And they're both like terms because they have no variable. Let's look at example B. So the first thing I see is 2u squared. Let's keep looking through these terms to see if there's any term that also has the variable u that's being raised to the second power. It looks like this one has a u, which is squared, but it also has a v, so it wouldn't be a like term. Let's keep going. It looks like 4u squared would work because it has a u and it's being squared. And it looks like that's all. So this last term would be really similar to this 3u squared v. So it wouldn't be one of the purple ones. Instead, I can make 3u squared v and 4u squared v like terms because they have the same variables and they're being raised to the same exponents. 2uv looks like it's not similar to anything else. And then 1/2 u looks like it's not similar to anything else as well. So those are my only like terms there. Let's go to the next question. Let's start with 3xz. So what's similar to 3xz? It looks like 9xz is similar. And also 2zx is similar. So remember, in order for them to be like terms, they have to contain the same variables, and those variables have to be raised to the same exponent. So 2zx has both of its variables raised to an exponent of 1. Even though it's in a different order, it doesn't matter. It's still a like term because it has the same variables, and those variables are being raised to the same exponent. Next, we can look at 7xy. That looks like it's similar to 12xy as well as 3yx. 8 looks like it's not similar to anything else. And 2x squared z looks like it's not similar to anything else as well. Any two opposite tiles add to 0. They form something called a zero pair. So for example, if I look at the algebra blocks that are provided to me, it looks like I have a positive 1 being added up with a negative 1. Now positive 1 plus negative 1 equals 0. In the next one, it looks like I have a positive x as well as a negative x. And positive x plus negative x equals 0. In this last one over here, it looks like I have a positive x squared being added up with a negative x squared. So a positive x squared plus a negative x squared equals 0. Organize the following algebra tiles into groups of like tiles. Remove the zero pairs and write the simplified expression. So it looks like I have one positive x squared. Ooh, and let's not forget to put an equal sign here. And then it looks like I have two negative x squareds. So the way I like to put my negative x squares is I like to put it just below. So that way I can cross off my zero pairs, just like that. Or the way we might have done it in class. Oh, Bear with me. The way we might have done it in class is I might have drawn a line like this through it. Let's keep going though. Let's keep putting my like terms down. It looks like I have 3 x's and then it looks like I have 1, 2, 3, 4 positive ones and 1, 2 of the negative ones. So let me continue crossing off my 0 pairs. And now what do I have left? Well, it looks like I have a negative x squared plus 3x plus 2. So let me just write out the equation of what I have left. Negative x squared plus 3x plus 2. So that would be the algebraic expression represented by these algebra tiles. Simplify using algebra tiles if they help. So let's go ahead and do some simplifying with algebra tiles. So I have positive 4 x's and I have 3 negative x's. Let's cross out my 0 pairs. And it looks like what I have left is a positive x. Let's do the next one. I have 4 positive x squareds and I have 2 negative x squareds. Let's cross out my 0 pairs. And it looks like what I have left is 2 positive x squareds. I'm going to stop the video here, but before I do, I want you guys to try C and D, and then we'll take up C and D in part 3.